our solar system might have some more planets up its sleeve. We know about 8 official planets, but they're not the only ones that survived the chaotic formation of our solar system 4.5 billion years ago. Astronomers say there are 3 categories of planets in our solar system. We're in the first one, the 4 rocky inner planets, Mercury, Venus, Earth, and Mars, that peacefully orbit the Sun. They're located within the main asteroid belt that separates Mars from Jupiter, which is in category number 2. That one's a group of planets in the outer solar system, the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets have huge amounts of ice and gas around what scientists believe to be their rocky cores. The third group lies beyond the area where our local planets are, somewhere further than Neptune. It's the realm where you'll find dwarf planets such as Pluto, Eris, and Sedna, and many smaller space bodies like comets. But new findings say there could be something else lurking in the dark, besides dwarf planets and tiny space bodies. Maybe even a new planet. Models scientists made say that our solar system used to have 1 or more rocky planets, the size of Mars or Earth. Over time, these rocky wanderers interacted with the wide gravity fields of our gas giants. This kicked them into a far-out orbit, away from the neighborhood. The question is, if one of those Mars-sized planets survived and could really be somewhere out there. Scientists have made simulations to see what potentially happened. These showed that in half of such cases where planets interact with the gravity of gas giants, they get ejected into interstellar space. In the remaining half, there's this one rogue planet left in an orbit similar to the ones the Kuiper Belt objects are following. There's only one thing left to do now: find it. Astronomers found the loneliest planet in the universe. They were trying to find distant brown dwarf stars, or failed stars, ones that never become massive enough to start shining. Stars are born with big masses, which means they also have strong self-gravity. The star squeezes in on itself. That causes high internal temperatures and enables the star to shine. But instead, they found a lonely wanderer, CFBD SIR 2149. The planet is between 50 and 120 million years old and has a surface temperature of 750 degrees Fahrenheit. Compared to stars, that's cold. At first, scientists thought it could be a brown dwarf star, but in that case, it would be way older. This starless planet floats around through space, passing only 130 light-years away from our planet. Our galaxy, the Milky Way, is 100,000 light-years wide, so that's relatively close. The lonely traveler is actually a gas giant, 4 to 7 times bigger than Jupiter. Maybe it was kicked out from its own solar system because of gravitational forces, or getting into another planet's orbit, or it was formed away from its parent star. Far beyond Pluto, on the edge of our solar system, there's a space body about as big as Pluto, but a little bit colder and way denser. It's probably a big rocky body covered in a thin icy mantle. It's the dwarf planet Eris. Both Pluto and Eris occupy the Kuiper Belt, which is the distant ring of frigid space bodies that lies beyond Neptune. A day there lasts 25.9 hours, pretty similar to Earth. But Eris circles our sun in the distance 3 times farther than Pluto, which means its year is pretty long, 557 Earth years. Eris has a bright, icy surface. It's one of the most reflective bodies in our solar system. It bounces back more than 95% of the light that strikes it. Somewhere out there, even farther, there's a super Saturn, J1407b, much larger than Jupiter or Saturn. It's an exoplanet, which means a planet that orbits a star other than our Sun. Super Saturn is 434 light-years away from Earth in the constellation of Centaurus. It's the only exoplanet we know about with rings similar to Saturn. It actually has a huge ring system, 200 times bigger than Saturn's rings. There are more than 30 rings, each of them tens of millions of miles in diameter. There are gaps in the rings, which means there could be some interesting satellites, exomoons, around. If this super Saturn could swap places with our regular Saturn, its rings would absolutely dominate our sky. You could look up and easily see them. The view would be amazing because they would appear much bigger than a full moon. Scientists have found thousands of planets outside of our solar system. Some are dense as iron, while others are airy and light. And then there's the water world, GJ1214b, a steamy world, bigger than Earth and smaller than Uranus, 40 light-years away from us, in the constellation of Ophiuchus. It's a watery planet surrounded by a thick atmosphere, 2.7 times Earth's diameter, and almost 7 times heavier than our home planet. It was most likely formed somewhere farther from its star, where there was plenty of water ice, but later migrated to where it is today. Its surface temperature is 440 degrees Fahrenheit, which is too hot to host life like on Earth. It also has much less rock and much more water than our planet. Imagine a planet with no land, but only endless oceans covering all of its surface. High pressures and temperatures would form things like superfluid water or hot ice, some pretty exotic materials that we can't see on our planet. Gliese 436b. It's a Neptune-sized exoplanet 30 light-years away from our planet in the constellation of Leo. It makes one full orbit around its star in a little more than 2 days. This planet defies the laws of physics. It orbits its star, Gliese 436, which is smaller, cooler, and less luminous than our Sun, at a distance 15 times closer than Mercury is to the Sun. When we typically think of ice, we picture a frozen cube. But this planet has an icy surface, even though the temperature there is 980 degrees Fahrenheit. This temperature is way above the melting point, but the ice remains solid and burning hot. This happens because of very strong gravity. It compresses the water vapor in the atmosphere into solid ice. The pressure here doesn't allow the ice to melt, no matter how hot the surface is. Now imagine being on a mysterious planet and it suddenly starts raining sapphires and rubies. One distant exoplanet, HAT P7b, a gas giant 1,000 light-years away from Earth in the constellation of Cygnus and 16 times bigger, has specific weather and pretty violent storms. Rubies and sapphires are scattered across the planet when it's raining. On the planet's night side, there's a high amount of corundum in the atmosphere. And corundum is what mineral gems such as sapphires and rubies are made of. Clouds of corundum give such an amazing view. The planet is plagued by severe winds that often turn into powerful storms that push huge masses of those clouds across the planet. Although the planet is uninhabitable, it would certainly be cool to come there and pick up some gems. Still, the weather is pretty wild. Plus, the temperatures are over 4,600 degrees Fahrenheit. By comparison, Venus is the hottest planet in our solar system, and its temperature is only 900 degrees Fahrenheit. Looking over the expanse of space, you can see a beautiful little blue dot in the endless darkness. It's an exoplanet, HD 189733b, that lies 63 light-years from us in the constellation of Vulpecula. But it's way hotter and larger than our planet, around the size of Jupiter, and it completes its orbit around its host star in only 2.2 Earth days. That orbit is so close that the planet is most likely tidally locked. That means it's always showing only one face to its star, like our moon always shows one side to Earth. The weather here is crazy. The winds blow at up to 5,400 miles per hour, which is 7 times the speed of sound. The fastest wind on Earth only hit the mark of 230 miles per hour. And it gets better. The rain here is not made of water, but of molten glass. Clouds are made of silicate atoms and particles. They are the key element that gives the planet its cobalt blue color, not the reflection of oceans, which is the case with Earth. Earth used to be purple. Today, even when you look at our planet from space, you see a lot of green. The green we see in nature is there because of photosynthesis, the process where plants transform energy coming from the sun into energy they need to live and to produce oxygen for us. The main part of the process that gives plants the green color is the chlorophyll pigment. A long time ago, instead of chlorophyll, there was a molecule called retinol. Its pigments absorb yellow and green light and turn it into red and blue, so the Earth was more purple. And then there's a pink planet, GJ504b, far away from us, in the Virgo constellation, 4 times more massive than Jupiter. It's a newly formed exoplanet, around 160 million years old. By comparison, the Earth is 4.5 billion years old. If we could go there, we would see an incredible world that glows from the heat of its formation. Everything around you would be colored magenta.
So get this, Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
You look up at the night sky and see nothing. Okay, well, it's not nothing. You see stars, but not nearly enough. If the universe is filled with endless stars in every direction, why isn't the sky blazing with light? That's just one of many cosmic riddles that are still waiting for an answer. Why do black holes delete information? Why can't the universe agree on how fast it's expanding? Yeah, these paradoxes break rules so much that it feels like they're breaking reality itself. The universe is endless, right? Just stars on stars on stars stretching out into infinity. Well, if that's the case, then how come the night sky isn't lit up like Times Square on New Year's Eve? That's the heart of Olbers' paradox, named after 19th century astronomer Heinrich Olbers. He wasn't the first to notice the problem, but he made it famous by basically asking, if there are stars in every direction, shouldn't the whole sky be glowing? You might think they're just too far. But in an endless universe, every direction should eventually hit a star, and all that faint light should add up. So, why the darkness? Maybe the answer is that the universe isn't infinite in time. It had a beginning, the Big Bang. That means light from the most distant stars hadn't had enough time to reach us yet. And the light that has been traveling for billions of years, it's been stretched out so much by the expanding universe that it's now invisible to our eyes. So, that pitch black sky, it's not empty. It could be that it's full of light we just can't see. Maybe it's a clue, a sign that the universe has a beginning, a history that we have yet to uncover. Alright, so space is darker than it should be, but you know what's even weirder? It's also way too quiet. You probably wondered about this since elementary school. Okay, the universe is massive. There are billions of stars with planets orbiting them, and a bunch of those planets should be kinda like Earth, which means extraterrestrials, right? So, where are they? This is what we call the Fermi paradox. Back in the 1950s, physicist Enrico Fermi sat down and asked himself this very question. There are no signals from outer space, no laser beams, no weirdly coded messages, nothing. It's not like we haven't tried to say hello. In 1974, scientists used the giant Arecibo radio telescope to beam a binary-coded message into space. It included stuff like our DNA structure, a stick figure of a human, and even Earth's location in the solar system. And since sound can't travel in space, what we actually sent were radio waves traveling at the speed of light. The message is heading to a star cluster 25,000 light-years away. So even if those little green men pick it up the moment it arrives, the earliest we could get a response is in about 50,000 years. Okay, that's pretty far into the future. But wait, if we're out here sending signals, isn't it possible someone else did the same, like 150,000 years ago, or 500,000? Shouldn't something have reached us by now? Some extraterrestrial TikTok at least? The answer could be that we're the first technologically advanced civilization. Perhaps intelligent civilizations vanish with their stars. Or maybe they're not as friendly as we are, and they've been avoiding us for a reason. Here's a nerdy one. Maybe they're out there, but we're just not listening the right way because it's not us being advanced enough. What if extraterrestrial civilizations communicate using something completely different from what we do? Like quantum entanglement or some exotic tech we haven't even dreamed of yet. Or maybe they exist in a form we can't even comprehend. Anyway, let's move from the silence of space to its most terrifying feature, black holes. You've probably heard the basics. Black holes are regions of space where gravity is so intense that not even light can escape. But here is an interesting theory. Black holes might be breaking one of the most sacred rules in all of physics. It's called the black hole information paradox, and this one made my brain hurt. In quantum physics, there's a rule. Information can't vanish. Not diary secrets, but the data describing every particle's position, spin, and motion. The whole essence, so to speak. Even if you destroy something, like burning a book to ash, the atoms and energy are still around. And in theory, big emphasis on theory, if you had super advanced tools, you could still figure out what was written in that book based on the particles and energy left behind. But when something falls into a black hole, a star, a spaceship, a giant pizza, whatever, it disappears behind the event horizon. And then, over time, the black hole itself slowly evaporates by releasing tiny bits of energy called Hawking radiation. Here's the problem. Hawking radiation dribbles out like random static, carrying no obvious hint of what the black hole swallowed. And if the black hole disappears completely and that information never comes out, it's like the universe just deleted the file with no backup. That breaks the no information loss rule. Some scientists think the information might be hidden in the radiation, but scrambled in a way we don't understand yet. Others think it gets imprinted on the surface of the black hole. And some say maybe we've got something fundamentally wrong about how the universe works. Before we figure out that one, let's pull back from black holes and take a wider look at the universe itself. Because even the way it's expanding doesn't seem to add up. This one is called Hubble tension, and it's not about drama between scientists. It's about a simple question. How fast is the universe expanding? Now, this should be easy to measure, right? For people good at math, I mean. Turns out, scientists have two ways. One looks at the early universe using the glow left over from the Big Bang. The other checks how fast galaxies are moving today by watching exploding stars. Except here is something funny. Those two numbers don't match. You'd think maybe it's just a measuring glitch, like, oops, forgot to carry the 1, but nope. It's more like checking the speed limit sign and then pointing two radar guns at the same car, and both showing vastly different results. This cosmic disagreement might mean that dark energy, the thing driving the expansion of the universe, is changing over time. Or that there's some secret ingredient baked into the early universe we haven't discovered yet. Either way, the universe seems to be expanding in a way that breaks our models. So it's possible we're missing something big. Or that reality is playing by guidelines we haven't written down yet. Alright, we've talked about how black holes might erase information. However, there's something just as weird. What if things in the universe don't decide what they are until you look at them? That's basically the idea behind the observer effect. Imagine you're tossing tiny balls at a wall with two holes in it. You'd expect each ball to go through one hole or the other, right? But if those balls are actually particles, like photons or electrons, something weird happens. If no one's watching, they act more like waves, and they go through both holes at the same time. But the moment you try to watch them, they stop doing that. They choose one hole and act like regular balls again. It's as if reality holds its breath until we look, then locks in what it is. But were they? Or did our act of looking force the decision? Nobody's really sure. However, that's not all. We didn't even have time to get into the time symmetry paradox, where the math says time should flow both ways, but in real life, it only marches forward. Or the cosmic horizon paradox, which asks how far apart regions of the universe, too far to ever communicate, somehow ended up looking exactly the same. Or the simulation hypothesis, which, yeah, let's just say that one deserves its own video. These paradoxes aren't just cool thought experiments. They're clues, little cracks in the surface of reality, and that's what makes it so exciting. See you next time! A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic Anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball, but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. but they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes.
So astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch, or the fawn, in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle, that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new left-bot has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT 2024 WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole left-bot thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes – small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. Lisa will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real, and they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow! Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.